Welcome to JCE Connect. In today's presentation, I'll be discussing on pavement design module 4, stresses in rigid pavement. I'll be seeing different formulas, Westergaard's equation, modified Westergaard's equation in detail, and the required charts before starting the actual problems. So here in this table you can see in the left corner, first column, region or location. Here you can see the interior stress, edge stress and corner stress, that is SI, SE and SC for different regions: interior stress, edge stress and corner stress, represented as SI. This small spelling mistake here, SI, SE and SC for different, that is due to wheel load, Westergaard's equation, modified Westergaard's equation, and temperature or warping stress and frictional stress. For in the Westergaard's equation you can see three formulas: ST, SC and SC. Here you can see that is for different P values. Capital P is nothing but the wheel load, H is the thickness of the slab, L is relative stiffness, radius of relative stiffness, B for which we have the equation, that is equivalent radius of resisting section when A is less than 1.72 and when it is equal to, that time you can directly take it as A, right? And next is the other formula, similarly for modified Westergaard's equation. Here for internal stress SI there is no equation, only for edge and corner stress we have the formula. Here also all the P value, H values are same except mu. And the next is temperature stress, warping stress. Here we will get STI, STE and STC. What is this ST? T is temperature stress. T stands for temperature stress, right? And here you can see capital E is modulus of elasticity of concrete. E is coefficient of thermal equation, small e, and T is T2 minus T1, or change in temperature between the top and bottom of the slab. And next is mu is Poisson's ratio. Next is Cx and Cy. From graph we will get, that is Cx is Lx by L and Cy is equal to Ly by L, and this you are going to get it directly from the graph that we'll see in the later part of the presentation. Next is similarly for STE and STC for internal, edge and corner stresses, three different equations, right? And next is frictional stress. We have the formula SF is equal to WLF into divided by 2 into 10 raised to actually it is minus 4. So we are discussing this frictional stress. SF is equal to WLF divided by 2 into 10 raised to minus 4. We'll see it's minus 4. It's very important that these formulas need to be remembered. Stress equation for interior, edge and corner, very important. And this, if they are not giving these any of these values like L, B and other things, they will be providing you the chart to directly find the stresses. For example, edge stress and corner stress you can directly find from the given charts that we will discuss in the further presentation. And similarly modified equation, two modified Westergaard's equation, two equations, temperature and frictional stress. You need to remember these formulas, right? Very simple. Just you need to practice once or twice and you will be able to find the difference between Westergaard's equation, modified Westergaard's equation, right? Next, coming to the uh, uh, critical combination of stresses. uh, they may ask critical combination of stresses. Already I have calculated the other stresses in the previous formulas. During summer, uh, critical combination of stress. During winter, these are the formulas at the edge region and at the corner region, right? Next, coming to the charts, here you can see the edge load stress chart as per IRC. Next, corner load chart, stress chart as per IRC. These they have mentioned at the bottom what is that particular chart. And coming to the individual charts, here you can see they are given the load, they are given the E. What is E? Modulus of elasticity of concrete. Next, they are given mu, modulus uh, Poisson's ratio, and different K values they are given, right? And with these P, E and mu and given K values, you can easily find these stresses and the edge and corner. For this, on the x-axis we have, that is slab thickness, from 14 to 25, like this. Slab thickness is given in centimeters, small h. For example, if you are finding it for 20, respectively, say k is 8, then say 28 is the uh, stress, that is in kg per centimeter square, right? So like this you can easily find the corner stress in kg per centimeter square. No need to calculate with the formula, right? Similarly, in case of corner, for particular value I can refer the inclined K values, and directly with the help of thickness you can find the stress in kg per centimeter square. Next is warping stress coefficient, that is Cx and Cy. How to find? For this we have an x-axis, this Lx by L and Ly by L. Lx is nothing but the length of panel and Ly is width of panel, and small l is radius of relative stiffness. So from that you can easily find, for example, for 6, what is how much is the value you can find, that is respectively Cx value. Similarly, what is Ly by L, respectively you can find the values, right? So like this you can find the stresses, all the stresses from the given formulas. Westergaard's equation, modified Westergaard's equation, temperature stress, and frictional stress, and given charts. So please uh, practice these formulas, and we'll in the next presentation we'll see some of the examination problems. Thank you very much. Please do like and subscribe.